Okay, let's talk about calculus. You know, there's this one little piece of algebra that trips up almost everyone. And it's not the big, scary concepts like limits or derivatives. Nope, it's all about mastering a single, crucial substitution. If you can get this right, trust me, you are halfway there. So let's break it down.
So this is the beast. This is the formal definition of a derivative, and it's basically the engine that powers most of intro calculus. I know, it looks super complicated, right? You've got limits, you've got fractions, functions inside of other functions, but here's the secret, and I really mean this. The calculus part, that's actually the easy part.
The real problem, the place where almost all the mistakes happen, is right here. This little piece, f of x plus h. And get this, it's not a calculus problem at all. It is pure 100% algebra. And I promise you, by the end of this, you're going to look at it and think it's easy.
Now to handle f of x plus h perfectly every time, you don't need some huge, complicated toolbox. You really just need a few key tools, all sharpened up and ready to go. So let's make sure they're in your kit. These right here are the absolute fundamentals. You've got to have these expansion rules memorized cold. How to square a binomial, how to cube one, and of course, how to distribute a negative. Seriously, they're the bedrock for everything we're about to do. Okay, pay close attention to this one. This is, without a doubt, the single most common mistake in algebra. They even have a name for it, the freshman's dream. It is so tempting to just say x plus h squared is x squared plus h squared. But no, that is totally wrong. You have to remember what squaring means. It's x plus h times another x plus h. And when you multiply that out, using FOIL, you get that crucial middle term, the 2xh. Getting this into your head is absolutely critical. And here's the other big trap. You have to treat that negative sign outside of parentheses like a light switch that flips the sign of every single term inside. It doesn't just hit the x, it also hits the h. So negative times x plus h becomes negative x and negative h. It seems like a tiny detail, but it can completely wreck your final answer if you miss it. Okay, so our tools are sharp. Now let's look at the blueprint. To dodge all those common mistakes, we're going to use a really simple, repeatable process that turns this whole thing from a complex problem into a series of super easy, almost mechanical steps. And here it is, the foolproof four-step method. It's super simple. First, create a skeleton of the function. Just rewrite it, but with empty parentheses wherever you see an x. Step 2, plug in x plus h into every single one of those empty spots. Third, you expand. This is where you use those rules we just talked about for exponents. And finally, step 4, you distribute any numbers that are hanging out on the outside. Seriously, think of this structure as your safety net. It'll catch those common errors. Let's see this process in action. We'll start with a nice, simple linear function. It's a great way to build some confidence and see just how clean this method really is. So, given f of x equals 3x minus 5, our job is to find f of x plus h.
Okay, let's walk through it. Step 1, the skeleton is just 3 times parentheses minus 5. Easy. Step 2, we plug in the x plus h. Now for step 3, well, step 4 really, we distribute the 3. We get 3x plus 3h. And that's it. 3x plus 3h minus 5. Since there wasn't an exponent, we got to skip the whole expand step. See? Simple and clean.
All right, time to level up a little bit. Now we're dealing with a quadratic function. This one's going to need all of our steps, including that super important expansion of a squared binomial. The function is g of x equals x squared minus 4x.
All right, let's do this. Step 1, the skeleton and substitute. We get x plus h squared minus 4 times x plus h. Now, step 2, this is the big one. We have to expand that square, and what does it become? X squared plus 2xh plus h squared. Do not forget that middle term. Finally, step 3 is to distribute that negative 4. So negative 4 times x is negative 4x, and negative 4 times h is negative 4h. And if you look at all those pieces, none of them are like terms, so that's it. We're done.
Okay, so we've totally mastered this one piece of the puzzle. Now let's see how it fits back into the bigger picture. This next example is basically a sneak peek of how you'll set up a real derivative problem. This is where all that practice pays off. So here is our challenge. We have the function h of x equals 1 over x. Our job is to simplify the expression h of x plus h minus h of x. This is exactly the kind of thing you'll be doing on day 1 of differential calculus.
The first step is just a straight substitution. We replace h of x plus h with 1 over x plus h, and we replace h of x with 1 over x. So now we've got a brand new algebra problem, subtracting two fractions.
To subtract fractions, what do we need? A common denominator. The easiest way to get one here is just to multiply the two denominators together. So our common denominator is x times x plus h. This slide just shows how we adjust each fraction to get that same base.
Great. Now we can combine the numerators over that single denominator. And look, here's where our toolkit comes in handy again. We've got x minus the entire group x plus h. So that negative has to distribute to both the x and the h, giving us x minus h.
And what happens next? Well, the x and the minus x up top cancel each other out, leaving us with just a negative h. So our final, simplified answer is negative h, all divided by x times x plus h. If you followed that, congratulations, you just navigated the trickiest algebra part of a very common calculus problem.
So we've been deep in the math, but you might be thinking, okay, but why? When am I ever going to use this? Well, let's zoom out from the abstract algebra and look at a very real-world application where this exact skill is absolutely crucial.
In business and economics, there's this huge concept called marginal cost. Simply put, it's the answer to the question, how much more does it cost to make just one more of something? You know, if you're making shoes, what's the extra cost to produce that 1,001st pair?
So just look at this formula for a second. If C of x is your total cost to produce x items, then the cost of making just one more is C of x plus 1 minus C of x. Wait a minute. Does that look familiar? It should. It's exactly the same structure as f of x plus h minus f of x. The only difference is that our little h here is just a number 1 for that one additional item.
And this is the payoff. This is why it matters. Businesses run this exact calculation all the time. If the price they can sell that next widget for is more than the marginal cost to make it, guess what? They make more. If it costs more to make it than they can sell it for, they stop. This one algebraic skill is literally fundamental to making huge financial decisions.
So here's the bottom line. What feels like just another abstract algebra exercise is actually the key. Mastering f of x plus h isn't just about getting a good grade on a quiz. It's about unlocking the door to the most powerful ideas in calculus, which then unlocks your understanding of economics, physics, engineering, you name it.
So by breaking it all down, by really focusing on those common mistakes, and by using a clear step-by-step process, we've basically turned the thing that used to be a gatekeeper into a gateway. You have the key now. You really do. The only question left is, are you ready to unlock calculus?